So you're going to have to forgive me because I have a, I don't know how to say it in English, machete. Cheat sheet, that sounds right. Because I have a memory and I'm nervous and I have to speak in English and it's kind of a lot of things to do, you know? So let's start. Yes, first introducing myself. Well, I am Ricardo Moran. I work at the Universidad Interamericana. I have to do that there. No, okay. So I will step up. And now I'm going to show you some of the work I've been doing for the last couple of months. This is when I'm going to show you a smalltalk-programming-language translator. Yet another because we have already some translators. And what it is? Well, I think this slide is useless, but for completeness I will explain to you, especially after Ian's talk, but it's completely useless. But as a translator is simply a software that grabs some source code in one language, in this case Smalltalk, does some magic, and then it gives you as a result the same source code in another language, in this case C. So, as I said, there is nothing new under the sun. We have already, especially in our community, a lot of examples. For instance, slang, which is used to build swing and follow VMs. Also, it's very popular now translating to JavaScript. We have Smalltalk to JavaScript, which is, I think, another one. which is a dialect of Smalltalk that is translated to JavaScript. Also, is very popular Ambertalk, which is really cool. And now the new kid on the block from Google, which is Dart. Actually, it has its own VM, but it's also translated to JavaScript. So it's not new. So you might wonder, why am I doing this? It's already done a lot of time. Before, no? So one of the reasons is because I can. Although there are a lot of other implementations, this is mine, and I'm going to show you. It might not be the best one, it might not be even be a good one, but it's my child, so I want to show you. But in a more serious reason, I'm one of the developers of Physicalitos. I don't know if you know it, but it's a visual programming language for kids to work with robots. And to work with robots like the Lego Next Kits, which is the ones on the top, and also with Arduino boards like this one, which is simply a physical board where you connect and devices like LEDs, buttons, and stuff like that. So I need to program robots with Physicalitos, and Physicalitos historically has been a good software for communicating with the robots, but all the programming, all the behavior was running on the computer and not in the robot. So it's very good for connecting with other devices like Microsoft Kinect's sensor, but for even basic autonomous tasks, it's not good enough. It's not fast enough, especially. If you think about it, if you have an autonomous car that has to ride correctly in a street, in 1 second a lot of things can happen, and you can't, and the latency of the communication is not fast enough for autonomous tasks like that. So one idea to solve this problem was, well, we have these scripts in English, that those scripts are actually Smalltalk code. Then we'll translate this into a language that the robots can understand. And in this case, we found that even the Lego Nest and the Arduino there exist compilers of C and C++. So that's the reason why I'm doing this translator, because I want to run robots with this kind of in Smalltalk. And also because it's interesting and it's fun, and I never done it before, and it's a nice way to learn, you know. Actually, I know very little about C, so this is also a good way of learning C and banging my head against the wall many times. So how? Well, first of all, the first thing I had to do was to define as the smalltalk subset I want to translate, because we have the entire smalltalk image that represents smalltalk image, and it doesn't make sense to translate everything in the entire image. So I want to define very explicitly the small subset that is going to be translated into C. This is important for me, at least, because I want the user to know exactly what he can write and what he can't write. So this should be crystal clear for me. So the way I did this was to define a new hierarchy. I don't know how to pronounce this, but and I did it like this. I defined a root, a C object that is responsible for the comparison operators, the instance creation methods, and stuff like that. And then I did subclasses. Everything that you have as a subclass of C object is directly translated to C. So if you can also always extend this, it's not static, it's so easy. And we have, for instance, well, sending list was just an experiment from me. It kind of works, it's not quite there yet, but we have separated type, that those are the types that they are, you can find in C. So those types translate directly to the keyword equivalent of C, except well, C block that actually should be translated to a function, but that's not done yet. But it's C boolean, C numbers, C string, and C void. C void shouldn't be there anymore because I don't have void anymore. But anyway, the others, yes. And all these classes contain the implementation of the kernel. I mean the control structures, the primitives or arithmetic operations. I mean, in Boolean you will have the if true false implemented, so you can see. This is important because also for proximity, you can see how the translation is implemented, how the primitives as directly C code are implemented, and you can also change them. So this is important. And the yes, of course.
Talking about the C block, you should translate into.
What?
Talking about C blocks.
Yes.
You could translate into iterator.
Not yet. Actually, I want those methods are implemented as primitives I don't have collection here, so for now that's not supported. But
it's really hard.
But since I don't have collections yet, I didn't care about that. But we see the later how to implement that sort of stuff. But so this is the core of the subset of smalltalk that is translated to C. And well, C program has a lot of useful methods for translating. Like you have C program, a subclass of C program, and you can send it translated to C and do it with the actual function translated. So next, how to implement the options. I use the methods. No, I use the C pragma I invented. For implementing primitives, something like this. In number, the multiplication operator is done as inline C code inside this pragma. The number is inside this code. The in brackets represent the receiver in the case of 0, and each parameter from So this, whenever the translator finds a call to for instance, if true or false, it will grab this string and it will replace each of the. Well, you understand, I think. So this is cool because you can extend the system with your own primitives by using the same format. So you see how the code is translated, and it has another cool characteristic that is that in this case all the methods are empty, but nothing prevents you from implementing the exact same code that will be executed when you're using an interpreter, for instance. I haven't made an interpreter yet, but you could make implement if true inside the method body. and when the interpreter runs it, it ignores the pragma and uses the implementation, and when you are compiling it, uses the pragma. So that's also very interesting at least for me. And that for now is that. Another problem I have is that I need static typing for now. I have to declare types for all the variables I have. So I have this, for instance, in the definition of the class, I made the instance variable types parameters when you set the types of each variable. Also I use pragmas like return type, app types, and 10 types that is not there, but it should be. So always you have to remember to declare types, otherwise it won't work. That's kind of a pity, but for now it's necessary. I believe it could be automatically inferred in the future, but I haven't done it before. I have done it because in English I have the types of the options, so I don't care. So yes, that's all for now. Now, also we can extend the system by implementing smalltalk methods. For instance, I was working with the LemonX firmware, and the LemonX firmware has very poor support for mathematic functions. It didn't have the syn method. So if you look at this, it is almost exactly the same as the syn method in integer, I think. I don't know, in float, probably. In number, I don't know. But I just copied it from the smalltalk class into the C translatable number class, and you see that it uses the primitives and it just works. This will be translated to the C code using the primitive. So you can also extend the system by implementing your own methods that call the primitives. So that's cool, I think. Well, now I have to explain how the translator works. This is very simple. I have some rules. The smalltalk classes will be translated to C structs. The stats variables will be translated to variables from construct. The methods will be functions which we have the receiver as the first argument. The blocks will be translated as functions. That's not done yet. The blocks are only allowed now inside the control structures, like if you while you and stuff like that. Class variables, I haven't implemented them yet. I don't know how to make them. Maybe like globals or something like that. Class instance variables, I was thinking about implementing a struct that represents the class side of the object that I haven't done that yet. And conditional, I don't even know what those are, so I haven't implemented them. Those are open questions that I don't get right now, but you know. So I have two translators actually, not just one. I have one that is like a low-level translator that is, I call it the method translator, that deals with source code. So this will translate one method at a time, and I have the program translator that is like high-level, looks everything, and it deals with the classes and its dependencies. See? So that's it. In the method translator, you say, well, translate this method, and it will give you the result. And the program translator, you say, well, translate this class, and you don't have to worry about dependencies and stuff like that. So the method translator, first it passes the source code with the factorial logic parser. That's very cool because I don't have to build that parser for smalltalk. I will already have one, another one. I'm using the array parser because it's simpler than the Squeak parser. I started using the Squeak parser, but it's much harder to understand. It has a lot of stuff. And one day, Serge Tinkish recommended me to use the array parser, and I started doing that, and it was a very good advice. Then, once we have the AST, we use the visitor pattern to translate each node. This is very simple, you know, almost very simple. And then As I said, the method translator only cares about the method that he's translating. If he finds a message sent to another method, it will send a notification, and also for every instance it found. So whoever called the method translator should handle these notifications and do what is needed, you know. So that's how the method translator works. It's very simple. We have the program translator. I don't know why the Chinese photo, but I didn't have a photo and I put random image in Google Images and Chinese appeared, and I thought, well, it's a good image. So the program translator uses the method translator to translate an entire class. It's usually a C program to class, but it's not necessary. It could be anything that inherits from the C object. It handles the notification from the method translator, so when it finds a method to be implemented, it calls the method translator to implement that, and adds, if it adds an int var, it adds the int var, it translates if the method belongs from another class, it translates the entire class, and it deals with everything. So, and it discards and reference methods and int vars. So you could have a big object and it won't get translated entirely. So the way the program translator does that is that it starts from a main method that you say, well, start translating this method, and it will go recursively translating each method called from it. So that's how it discards all the unreferenced code. So this is important because these words have tiny memory and I need to optimize that. It kind of works. Also, I said that it works for C and C++, so how does it work? Actually, the program translator and the method translator do not give you a string as a result. It gives you an object that represents a program, an object that represents a method, and stuff like that. So I'm using an abstract factory to support all the syntaxes. Most of the time, the differences in syntax are only how you organize the methods and how they are the source files you create. So for instance, I have here not exactly C, which is used for translating Lego Next to the Lego Next robot, and Arduino C, which is somewhat, no, it's actually C++, but with a few things more limited. So I'm not actually translating to C. I build the program parts, and every factory gets its own objects, so you don't have to worry about it. These objects are responsible for organizing the code and creating the source files that you need. So another thing that I have to do is integrate the physical items. So for physical items, what I did is to create as a new slot in the object. Every graphical object has a new slot that is called a mode, that it will let you switch between direct mode when you communicate with the object directly, and compile mode. So that's something I did, and also I modified the script editors. I don't know if any of you know Ethos, but that's a modified script editor where here I usually have a ticking clock that will make the script run, and here I have the state of the clock. So I modified it to have a button to compile and reload, and here you can say how many times per second will be run. So also integration with editors. To integrate with editors, I have to add another step before the actual translation, because I have the iteration-generated code, which are small classes, which are the behavior of the script, and I have to give them to a player translator, which should merge them into one class that is translated to C. So I have each morph object has its own class, and they are not actually translated until I merge them into one smalltalk code that is translated to C. This class has all the methods and all the int vars from the other merged classes, and I use something like name mangling for avoid collision, and also I have to create manually the processing of the scripts. So all the scripts, it always has something like all the scripts are running in parallel or something like that, and I have to simulate it in the code. I will show you later how that's done. So I now have one smalltalk class that is translated to C, and I give it to C translator, and it generates the C code, and the C code is given to G3, AW, and NBC, which are each compilers I'm using, and that is compiled inside the mode, and now it runs without the computer. So before the demo, I will talk about the non-support features yet. One is of course dynamic data type, because as you see I have to declare the types of the virus. I don't know if I think it could be inferred automatically, but I can't do it yet. In any smalltalk methods, I wanted at first to be able to say, well, okay, this method will be inline and put a pragma there, and all the code will be translated and placed in the place of the column, you know. I've traveled a lot about that because I wanted to have all the cases covered. It was a bit work, and then I realized it doesn't matter because what I'm trying to say is not speed, but program space, so it's useless. So, another thing I don't support is polymorphism. I don't know how to do it yet, especially with primitive types, because I don't want to have an entire struct even for a number. That doesn't make sense because it would be too expensive. I don't have it. Some sort of inheritance is done. It's kind of a dog alambre, but it works. Well, those closures I told you I think how to implement that. It's very difficult, especially with the non-local return, that I don't know how to, well, the next is that I don't know yet how to do it, but the thing is that for the purpose of my work, translating physical which is much, physical doesn't even care about the stuff, it's much simpler than this. So you might be saying, okay, without this it's not smalltalk, and you will be right, that this is not really smalltalk, but it works for me, and I don't think I will going to be implemented in the near future. So anyway, it's time for them. I don't know. I have a few minutes, so I will show you. I have here an Arduino board. You can see it, and I will show you how to build a simple, I think, a simple program that will use a button, and will turn on an error. So I will make a program. Also I don't have a robot built because now is the conference from the Universidad de Rosario, and they took everything interesting there. So I agree with the less interesting stuff, and also the stuff that is not even finished. The Lego stuff is complete, but I don't have it here. So I will show you some toy examples, but you will understand. So I will do some example. It's important to be a subclass of Arduino Sketch because it has a lot of primitives that belong to Arduino, you know, so to turn on a pin or get the value, read the value of a pin. So we use that. I have to implement I have to implement a setup method. I will use a button in the pin 12, and I will use a salient in the pin 11. So now we will say, okay, we will declare button as we said 12 and 11, and we have to set up first the mode of the pin. So I will say self pin button mode input, because we're going to read from that, and pin there mode output. You know? So I have set that. You might not know this image because it's a long time ago image from Spring, but it is what we use in English currently. And now we are going to implement a method that we run in every cycle. So we will call loop, and we will say, okay, self digital write value cell, digital, read. So whenever we press the button, it should be translated to. See, this is simple code, very simple, not even a good example. And now we will see how it generates the code. Now we call it example program. And we can see how what does it generate. Okay. Example program. Everything can happen. I know what happened. I didn't. You remember I told you about the static typing? I have to declare this as CPy and C. See? The error is not very understandable. And now we have C++. I don't know if I not bad. You can see that it's simple class called example program. The main method creates a new example program and it calls main. And the main method actually calls init, which is an Arduino method that initializes the board, and then calls it up, and eternal loop, it calls the method loop, and loop is translated as digital write, etc. And it should run if we can see if it has some syntax error. This actually calls the C++ compiler, and if there's an error, it should tell us now. That's finishing, so I have to hurry. I can. And it seems to work well because it tells you, it is telling us the size of the program, and it's very small, and we can compile it to the Arduino by doing this, and it will upload the program inside the keyboard. Yes. So once this is finished, if it doesn't give any error, which I wish it won't, whenever I press the button, it should turn on the letter. So that's as simple as it is. We can also use other sensors, but I will show you now very quickly how does the itoist part work, which is the most important part of this for me. We have here an object that represents the Arduino. We say, okay, the mode will be compiled, the count is com3, and the type of Arduino is that, so we connect it, it's connected now. We say that we have a button in the pin 12 and a LED in the pin 11, and now we should say, okay, we open a viewer, this is how we program in physicalities, and whenever the button is pressed, actually it should be much easier. I don't need it, but it doesn't matter. If the button is pressed, we turn on the LED. Yes, and I will make this 100 bits per second. Now, if we compile, it does the same. Actually, it makes a bigger program because I have to deal with other special cases in English, but it should work the same. And so let's see. It finished okay, and so that it should be working again, but with itoist code. See? I don't think I have time for another demonstration. I want to use some analog input, but I also want to show how, because you might not believe me, this is still connected to the computer because of I needed the alimentation. So I will connect this quickly inside here, and it should work without any connection to the computer. And as you can see, the program is actually running here. So that's all for now. And well, thank you very much. That's our blog. You can find anything, and the blog is there for you to touch, right? Thank you.